Welcome back to another exciting episode of Mr. Takeda Teaches Algebra. I'm your host, Mr. Takeda, and I'm going to teach you some algebra. This is lesson 7.2 on multiplying polynomials. In our previous lesson, we learned what polynomials were, right? The sum of monomials. And we learned how to add and subtract. And this time we're going to learn how to multiply them. So I want to give you a little background first, and I really want you to understand that polynomials are just a number, right? They're just really a number with some unknowns in them. So let's talk about multiplying some two-digit numbers here. Now, you don't have to take this down in your notes, but I just want you to pay attention to this. And this first thing we're going to do is called basically the traditional algorithm. This is how you're kind of taught to do it in elementary school. 5 times 7 is 35. We carry that 3, right? 35. 7 times 4 is 28. And then to that 28, we add the 3. 28, 29, 30, 31. So 31. And then we put a 0. And then we move to this 2. And we go 2 times 5 is 10. Sorry, the 1. 4 times 2 is 8. 8 plus 1 is 9. And then we add all this up. 5, 1. 9 times 3 is 9 plus 3 is 12. 1, 2, 1, 5. Okay, now consider this. Now, the carrying and the adding and all that stuff, that's what we call a standard algorithm. Now, what if we do it this way? What if I do it this way? 5 times 7 is 35. And I just put the 35 right here like that. And 4 times 7 is 28. But it's not really 4 times 7, is it? It's 40 times 7, so 280. And over here, I've got 20 times 5, right? So I'll put another 0 here. 2 times 5 is 10. And finally, 20 times 40 is, I'll put 2 zeros, and then 800, right? 800. And if I add all this up, 5, that's 11. And then I've got 8, 9, 10, 11, 12, 1, 2, 1, 5 still, right? So without the carrying and everything, I have 4 numbers here I'm adding up. And this is really what I want to kind of bring out to you here. These 4, when we multiply a 2-digit number times a 2-digit number, we actually have, we're actually multiplying 4 times. And we get what we call these 4 partial products. Products because they're the result of multiplying parts of these numbers together. So we're multiplying. To add them all up, that's when we get this our final product here. Okay. Now, what if I write it this way? Well, I still have to multiply 4 times, and that's kind of the idea here. And it doesn't really matter what order I multiply this in. I just have to make sure I multiply each thing over here by everything over here. So 40 times 20, we know that's 800. We saw that. 40 times 7, 280. 5 times 20 is 100. And 5 times 7 is 35. If I add that up, I'll still get the same 1,215. So I write it this way now because this is what binomials look like. That's what we're going to start with today. Start with is multiplying binomials. So I have x plus 2 times x plus 5. Well, just like I did in that previous example, I'm going to multiply x times x and get x squared. Then I'll multiply x times 5 and get 5x. Then, since I've multiplied this first term by every term over here, I move to this second term now, and I'll multiply this by both things over here. 2 times x, 2x, and 2 times 5 is 10. Now, our last thing to do is add everything up, but we can't add all this up, but I can combine like terms. And I do have like terms here in the middle, don't I? I have 5x and 2x. So I would add those together and get 7x. X squared plus 7x plus 10. This is our final product for multiplying these two binomials together. Okay? Pretty straightforward. We multiply each of these terms by every term over here. Let's try this one. This one's got a 2x in this. Same thing though. Let's go in order. 2x times x is 2x squared, and 2x times 5 is 10x. Now, negative 3 times x, remember this is a negative 3 now, we're multiplying terms. Negative 3 times x, negative 3x. And negative 3 times 5, negative 15. Okay, so again, I can combine like terms in the middle. 10x plus negative 3x, or 10x minus 3x, is 7x. 2x squared plus 7x minus 15. And you're saying, okay, well, that's all well and good. But what about multiplying binomials and trinomials or other bigger polynomials? Well, the idea stays the same. I'm going to multiply each of these terms over here by every term over here. So since I've got 2 terms times 3 terms, I should have 6 partial products now in my first go around. So x times x squared is x cubed. And then x times negative 3x is negative 3x squared. X times negative 2, negative 2x. Then we jump to the 5. 5 times x squared plus 5x squared. 5 times negative 3x, negative 15x. And then 5 times negative 2 is negative 10. 6 partial products. Right? 1, 2, 3, 4, 5, 6. And now we'll combine like terms, and I try to go in order. So x cubed, I have no other cubes here, so I can't add anything. I can't collect like terms with any other terms for my cube term. But I've got negative 3x squared and 5x squared, right? Negative 3x squared and 5x squared. Those are like terms. Combining those, I'll have 2x squared. And then I've got negative 2x and negative 15x. Those are like terms because they have the same variable with the same power. So that would be negative 17x. And then that leaves just the constant by itself at the end, so negative 10. And that's it. That's our simplified product for multiplying this binomial and this trinomial. And that's it for today. Pretty simple procedure. You got to keep things straight and organized. That's really the goal for this. And that's I'll see you in class next time. Bye-bye.